We cross multiply.
Okay, so what do you get?
2x.
Okay, cross multiply. X times x is not...
Oh, it's x squared, sorry.
Okay, that's all right.
And then it's equal to 36, and then x is equal to 6.
Yeah. Actually, x is equal to plus or minus 6, but they've told us that x is a positive number, so we choose the positive side of that. But that's a tricky concept when it comes to data sufficiencies. If you know x squared is equal to 36, do you know what x is? No.
No.
Okay.
And it's the same thing with absolute value.
Uh-huh. Okay, in this diagram, this big angle is B, the little angle is A.
What is b minus a? Well, you know that there's 180 total.
Okay. Now they're in a 7-to-2 relationship.
Yeah, I'm just trying to figure out how you use that.
Now, notice one thing about this problem. It's a little tough to back solve because they're not asking about B. They're asking about a quantity B minus A. So this is not a good candidate for back solving. Usually you want the final question to be a single thing.
I mean, but just looking at the numbers, you know that the answer is not E.
Okay?
Because for B minus A to be that, then B would have to be 180, which is the
Right.
total.
Right. Right.
I mean, except if, I guess, A is 10.
You could kind of back solve. It's not ideal for back solving, but it's not like you can't work it out. If C was the answer, what would the two angles be?
50 and 50?
They'd be 1/5, no, they'd be 140 and 40, right?
Oh, sorry, yeah.
Okay. Is that a 7-to-2 relationship?
What?
Is that a 7-to-2 relationship?
I want to say no.
Well, in other words, that's what it is. The zeros cancel, and that's equal to 7/2. Remember that 7-to-2 means B
right.
over A equals 7/2. And this one, they want to know what B plus A is. Well, we know, I'm sorry, they want to know what B minus A. Well, we know that B plus A is 180. Well, between those two equations, we can calculate A or B. And we'll come up with the answer of
Would you just
40.
isolate one of the...
Yeah, let's go through that. Because, okay, you solve for B or A. Let's go ahead and solve for B from the top equation. And now we'll substitute that into the lower equation. So 7A/2 plus A equals 180. And then solving this for A, we have 7A/2 plus a full A. Well, this is 3.5A. This is another A, so that's 4.5A equals 180.
Could you just multiply it by 2, like the whole thing?
Yep, I can do that. Let's multiply every term by 2. So we got 7A plus 2A equals 360. So 9A equals 360, A equals 40. And once you come up with A, coming up with B is pretty easy.
Okay.
But the back solving didn't work too badly. I mean, you kind of did, you ruled out E. Well, that's fine. We know it can't be E. One of these looks like a nice candidate, though. But do you see why I say that it's not ideal for back solving? Because to figure out that it's 100 forces us to figure out that that must be 140 and that 40. That's not that simple of a process. So solving this one algebraically is probably the better way. Okay, one of my favorite problems. A snail can move I inches in m minutes. At this rate, how many feet can it move in h hours?
Well, you told me that there is 12 inches into a foot.
Okay.
And there is 60 minutes to an hour.
Okay.
I can't see the last answer.
Unfortunately, I don't have it. It didn't come in the camera shot inside it. So hopefully our answer is one of these four.
So we have to set it up as a algebra.
If that's one way to do it. These problems are particularly difficult for me because there's combination of multiplication and division going on. And my brain just gets a little confused if I have to do both multiplication and division. So
yeah, well, what I'm thinking is that if we actually had, a number for inches and a number for minutes, and
there we go. In other words, this is a classic pick numbers problem because we have three variables in the stem, and all of our answers have those same three variables. So we can make up numbers and solve this real easily, and then whatever our solution is, whichever answer agrees with that number, that's our answer.
Okay.
So work me through the process. Work me through.
Inches.
I'm sorry, what?
So if we're going to pick numbers, you could just say that the snail can move 10 inches
Okay.
in, I don't know, 60 minutes,
Okay.
an hour.
Uh-huh.
And then you would just multiply the 10 by 12, right?
You would have to divide it.
Oh, divide it.
You see why? Let's go back and pick 12 inches.
Less than inches. The foot needs to be less.
Right. Let's make I 12 inches because that's going to make everything a little more understandable. So if it can move 12 inches in 60 minutes, how many feet can it move in h hours?
Well, if age is equal to 1 hour, it can move 1 foot in 1 hour.
So we know our answer is 1 foot. Now let's find out which of these comes out to be the number 1 using these three numbers. Well, 5 times 1 times 12 is 60 divided by 60. That comes out to 1.
1.
This one is 60 times 1 times 12 divided by 60. This comes out to be 12.
12 times 1,
12
right?
divided by 12 times 60. That doesn't work. This is 5 times 60 divided by 12. That doesn't work.
So the answer would be A.
Well, we don't know what E says. And it's possible sometimes when you do these problems that
Had
you'll
more
you'll
than
find
one.
2 more than 1. If that happens, go back and change your numbers. One different set of numbers will clarify which answer is correct.
Uh-huh.
And that's exactly how you do it. Now see, it seems to me, oh, I see. I see. I felt like we had to multiply by 60 and divide by 12. In other words, whatever answer we came up with should have been multiplied by 60 and divided by 12.
Why
That's
does
how we
it
get our
say
5. Yeah, why divide by, let's see, if you go, well, you got to divide by 12 because if you go 24 inches, you got to know that that's 2 feet. So you're going to have to divide I by 12 for sure. And you're going to have to multiply by H. And then we're going to have to divide by 60 to find out hours, to move hours in from minutes. So having this 5 in the numerator makes a lot of sense. We're going to need a 5 because we should have 60 in the numerator divided by 12 in the denominator. All right. Ooh.
Okay, she can grade T tests in 1x hours. At this rate, how many tests can she grade in x hours?
Yeah, she can grade t-tests in 1 over x hours.
Mm-hmm. Well, I mean, wouldn't you just have to pick some numbers again?
Yeah, we can do it that way. I'm just trying to conceptually see if I can figure it out directly. If I can grade 2 tests in 4 hours, then how many tests can I grade in 1/4 of an hour? Okay, let's try that. Make up some numbers for me.
So she can grade 2, so T is equal to 2,
Okay.
and X is equal to 5.
Okay, so she can grade 2 tests in 1/5 of an hour.
Mm-hmm.
So she can grade 2 tests in 1/5 hour. So how many tests can she grade in 5 hours?
Well,
Just
so
in 2,
she grades 2 tests every 12
right?
minutes,
So how many tests does
right?
she grade in an hour?
10?
So how many tests does she grade in 5 hours?
50?
So there's our answer. Using this for t and this for x. Now, which of these answers equals 50?
Okay, well, 2 times 5 is 10, so it's not A.
Okay.
It's B, because 5 squared is 25 times 2 is 50.
And none of these others come even close to 50, so
Mm-hmm.
that's actually a perfect one for picking numbers. Because it's a bit confusing the way they word it here. But once you've put numbers on it, the whole thing comes out rather nicely.
A club had 3 boys and 5 girls. During a membership drive, the same number of boys and girls joined the club. How many members does the club have now if the ratio of boys to girls is 3 to 4? Well, they had 8 people. 12?
The ratio of boys to girls now is 3 to 5, right?
3 to 4.
Well, if it started out 3 to 5. A membership, equal number of boys and girls join the club, and the new ratio is 3 to 4. So let's introduce, well, we could back solve it easily, right? Back solve this one.
Well, I would probably start with B, just because if that's
No, that's
the
correct, because we might be able to determine whether we go up or down in this case. So if 14 new members joined, what's the new ratio of boys to girls?
Oh, they're asking about how many members total the club has now,
Yeah.
right?
Yes. Started with 8. Some number joined, but an equal number of boys and an equal number of girls. So how many members does the club have now if the ratio of boys? Okay, I see what you're saying. So if we back solve this and we assume 14, then 6 members joined, right?
3 of each.
Okay, so the new ratio would be 3 plus 3 over 5 plus 3.
It would be over 6 over 8, which can be 3 over 4.
So our first guess worked.
Mm-hmm.
I'm not sure we would have known which way to go. If we would have started with, well, we can rule out D because it's odd.
Yeah, it has to be.
It has to be an even number. If C was the answer, that means 4 boys and 4 girls would have joined. So we would have had 7 over 9. That doesn't work. But the question is it also doesn't enlighten us very much as to whether we need to go down or up.
Mm-hmm.
So this might be a case where we have to try more than 2.
Yeah.
But we don't have to try D.
Mm-hmm.
And algebraically, we could say 3 plus x over 5 plus x has to equal 3 over 4, with x being the number of members that joined.
Mm-hmm.
So now if we cross multiply this, we get 12 plus 4x equals 15 plus 3x, x equals 3. 3 boys joined and 3 girls joined. So we had 6 new members. We started with 8. We get to 14.
Oh, because you end up with 15 minus 12.
Right. And then x is equal to 3.
Mm-hmm.
So we know 3 boys joined and 3 girls joined. 6 new members.
If 3x minus 1 divided by 25 is equal to x plus 5 divided by 11, would you cross multiply or would you...
First of all, I would check to see if there's any hidden things that might speed it up. In other words, if this side over here was 6x minus 2 instead of x plus 5, I would recognize that the numerator is exactly twice as big as this numerator. but I don't see anything in this. So I don't see any shortcuts, so yes, you can solve this directly by cross multiplying. So what's the
Okay,
next
well,
line?
so it will be 33x minus 11 equal to 25x plus 150?
125. If you have
125.
five quarters in your pocket, you got $1.25.
Mm-hmm.
I know that doesn't work quite as well with people who are from Denmark, but
Yeah.
you've probably been using American money enough by now.
Yeah, so then you have,
I move the x's over to the left and the numbers to the right.
so the answer is 17.
Uh-huh. And we don't even have to do that. They put such distance in between 17 and the next lowest and the next highest that we just know 17 has to be it.
Well, because you know that 8 times 7 is 56.
Okay,
You know?
yeah.
Yeah.
Yeah, we can do the math. Okay.
Okay, if 4 boys can shovel a driveway in 2 hours, how many minutes will it take 5 boys to do the job? So it takes 4 boys 120 minutes. Isn't that the work formula?
Mm,
You can't really use that here, though.
there's an easier way. I don't know if we can use it here or not. I don't think so. But that's probably not the way we want to do it.
Okay, well, obviously we can eliminate E and D.
Ian, oh, okay, because it has to
Because
be shorter
it's not
than
going to
100.
take them more
Right,
time, and it's not going to be the same time. So at
right,
least we can eliminate those.
right. I agree. Okay.
Um, well, could you just say that, I mean, 120 divided by 4 is equal to 30 minutes.
Okay. So the other way we could do this is if 4 boys take 120 minutes, what's 1 boy take?
Um, to do the whole, so, but I want to say 100, oh, you say 120 times 4, right?
Yeah, it's going to be 4 times longer if you just
Yeah,
have 1
like
boy
I kept
shoveling.
wanting to say divided by 4, but I was like, no, that's just what one person does within that.
Right.
Yeah.
Okay, so if the total job is a 480-minute boy job, how long does it take 5 boys to do that?
96.
Right. This number divided by 5. Let me just look at this for a moment.
If 500 pounds of mush will feed 20 pigs for a week, for how many days will 200 pounds of mush feed 14 pigs? Okay, so 500 pounds. That's a weird one.
Okay, so do it similar to the way we just did the previous one.
Okay, so 20 pigs, 500 pounds of mush equals to 20 pigs for 7 days.
Okay. Let's bring it down to 1 pig. 1 pig in a week eats how much?
25 pounds?
Of mush per pig per
So
week.
25 times the 14 is 350. So it doesn't quite feed them for a whole week.
How many days will 200 pounds of mush, well, it would feed, 200 pounds of mush would feed 1 pig 8 weeks, right? If I divide 200 pounds by 25, that's 8 week servings per pig. So 1 pig for 8 weeks would get 200 pounds of mush. 200 pounds per pig for 8 weeks. Well, we've got 14 pigs, so 8 weeks is 56 days. So clearly we're going to have to divide that by 14, and we get 4.
So what you're saying is that you figured out that 1 pig can eat 25 pounds of mush, right?
Right.
And then you took the 200 pounds divided by 25, which is 8.
Right. So 1 pig could live for 8 weeks on 200 pounds.
And then you said the 8 weeks is 56 days, and therefore that's divided by the 14 pigs, which is equal to 4 days.
Right. That's the way I did it. There's multiple ways to do it, I'm sure. But it's similar to the way I like to do work problems, is that I bring everything down to a single pig. Just like the last question, we figured out how long it would take 1 boy to shovel the driveway instead of 4 boys. So once we know the rate for 1 pig or 1 boy, then we're ready to tackle the rest of it. Okay, let's see. We're done with ratios and proportions. Now let's look at averages. You're pretty good with averages, but oh man, you're not going to be good on this one because we're going to have a hard time seeing it. No, I guess we'll be okay. Let's at least look at them before we move to the test.
So Michael's average on 4 tests is 80. So what does he need on his 5th test to raise his average to 84? Well,
Average problems are all about what? Total.
The sum divided by the
Total.
sum of the numbers divided by the total amount.
Just know that when you go to do an average problem, you're going to have to figure out totals. So what's the total score he's made on his first 4 tests?
320.
What's the total score he needs on all 5 tests?
80. He needed an average of 84.
So 5 times 84.
420.
So that's how many he has. That's how many he needs. The difference is how many he needs to score on his 5th test.
100. And
And I've never come across an average problem yet where you tried to compare this 80 with this 84. That just doesn't work real well. I mean, it can be done, but you got to really know what you're doing. And it usually always boils down to totals. We needed to multiply that 4 by that 80, and we need to multiply that 5 by that 84 to come up with the totals.
Mm-hmm.
Okay.
Okay. Well, Marilyn's average on 4 tests is 80, so the sum is 320.
Okay.
Assuming she can earn no more than 100 on any test, what is the least she can earn on her 5th test and still have a chance for an 85 average after 7 tests? Well, 85 times 7 is 595.
Okay, so she needs that for 7 tests.
Mm-hmm.
This is what she's got on 4 tests.
So what is the least that she can get?
Mm-hmm. Well, the least she can get on the 5th test would require her to get what on the 6th and 7th tests?
Yeah, well, she's missing 275 points.
Okay.
And
But when we're trying to solve for something that's the least, we want to take her other 2 tests and make them the most. You see what I'm saying?
yeah.
In other words, we're looking at a 5th test. What's the minimum she can get on that 5th test? Well, she would have to get...
60. It's not 60 because if you take 60 off of 275, you get 215, and she can only get top of 100.
Okay. Okay, that track will get you there.
She can't, 70 won't do it either.
Right.
She can do 75 if she gets 100 on both the 6th and the 7th.
Exactly. And that's the part of the logic that I was trying to point out, is that you want to assume she's going to get 100 on the 6th and 7th tests.
Mm-hmm.
And if you do that, well, that's 200 more. So she had 520. The minimum she can get on that 5th test is the difference between those two, 75.
Mm-hmm. Yeah, I mean, I know I might gotten there a little slower, but at least I just did the eliminating in my own head.
That's fine. I have no problem with that kind of math on these tests. You're essentially back solved.
Mm-hmm.
You knew 60 couldn't be right, and kind of got to the answer that way. So let's do one more average problem and then go to the tests.
Mm-hmm. Okay, so her average on 4 tests is 80, equals
Wow.
320. Which of the following cannot be the number of tests on which she earned exactly 80 points?
I like this question.
What?
I said I like this question.
Well,
Can it be 0? In other words, these basically are back-solving problems. You kind of have to
it
back
can't be
solve.
4 because then all of them would have to be 80.
So 4 works.
Which of the following cannot be the number of tests on which she earned exactly 80 points? Well, yeah, I guess it can
4.
be.
It can be 4.
Mm-hmm.
Can it be 0?
Yes, I mean, you could still get 320 and not have...
There's 0.
Mm-hmm.
Can it be 1?
Yes.
I could do a 79, a 79, and an 82.
Mm-hmm.
And the extra 2 over here makes up for the extra 1s there, so that works. Can it be 2?
Mm-hmm.
Okay, which means 3 is our answer, but why can't it be 3? Let's think about it for a moment before we go on. For it to be 3 precisely, why can't it be 3? Because if we had 3 80s, what could the fourth one be to still average 80? It'd have to be 80. So you can't have 3 80s. You got to have 4 80s or 2 or 1 or 0.
Mm-hmm.
But you can't have 3.
So the number is 3.
Huh?
The number is 3.
Right. Okay, let's... and my notes says we got to number 34 of the data sufficiencies on test 5. And we got to 33. All right, 35 is also data sufficiency. So let's
Yeah, yep. If the total price of 5 grocery items is $6.05, what is the price of the most expensive of these items? I think 2 is pretty easy to answer.
Yeah, I would almost base it out on the number of words. This is 2 sentences, that's 4. I'm usually always going to start with the shorter thing.
Mm-hmm. Well, that's 110 times 4, and then you will know what the last one costs.
Okay, so 2
So
works.
2 works.
Yeah, and it was not necessary for me to go through the math. I'm sorry, I shouldn't even have done it. Teaches bad
Oh,
habits.
2 works, so 2 is a yes.
Oops, excuse me. That's what I meant to write.
Oh, that's fine. The price of the most expensive item is exactly 50% greater than the price of each of the other 4 items. I want to say that that doesn't work because you don't know that the 4 other items cost the same.
Kind of do, because it says it's exactly 50% greater than the price of each of the other 4 items, which implies the other 4 items must be priced the same.
Hmm. Well, I can't see the math in my head, like how you would find out from that.
Well, I accidentally did, I knew there was a reason I accidentally did it. When I solved it based on 2, what did I come up with?
That's what you came up with
$1.65.
too.
$1.65. Well, $1.65 happens to be exactly 50% more than $1.10.
Mm-hmm.
So,
But you don't know that. You don't know that it's $1.10. Like you don't have if you're only looking at 1.
okay, so let's solve it mathematically, algebraically. Let's let X be the price of each of the other 4 items.
Mm-hmm.
So what do I know? I know that X plus X plus X plus X plus 1.5X
Mm-hmm.
equals 605.
Mm-hmm. Yep.
1 equation, 1 unknown, we're going to be able to solve it.
Yeah, because you just put all the x's together and then divide
Well,
by
this presumes, yeah, I have to presume that the price of each of those cheaper items is the same.
Mm-hmm.
I don't know how it couldn't be, because the 5th one is exactly 50% greater than the price of each of the other 4. So
Mm-hmm.
this equation should be valid. So either one on their own, let's pop open the answer thing for this thing.
D.
35 should be D. Okay. Let's see. Whoops. Let's test one. Don't have any more data sufficiencies. So we've done all the data sufficiencies on 4 and 5. Now I started with those because I had the answers on 4 and 5. I don't have them on 2 and 3 and 1, but that really shouldn't matter. Yeah, let's just go to test. Let's just do all the data sufficiencies. I mean, it's going to matter if we make a mistake and don't spot it. But so far we're doing okay here. Okay, so let's just do data sufficiencies. Number 3.
If x and y are integers, is x plus y minus 1 divisible by 3? When x is divided by 3, the remainder is 2.
It's got to be a no, right? Because why?
Well, x could be many numbers, but you won't know anything about y.
It doesn't address y. And if it doesn't address y and they're asking us whether x plus y minus 1 is divisible by 3, it doesn't look like that can help. If it doesn't say anything at all about y.
Yeah. And then 2 is no, because it doesn't say anything about x.
Same logic. So now to figure out whether both of them work, I would say let's start picking some numbers.
Well, x could be equal to 8.
Okay. So actually x could be equal to 2, 5, 8, clearly numbers separated by 3. Y is divided by 6, the remainder is 5, so what kind of numbers might these be? 11, 17, oops, hold on. Yeah, that's right. 23. The pattern here is that they're all separated by 6.
Okay, well, I guess we can just try some of them. 2 plus 11.
13 minus 1 is 12, so that works.
5 plus 17 is 21.
That works.
That's 30.
That works. So it would appear that yes, we can answer that.
Together, yeah.
Divisible by 3, yeah. And it doesn't matter. I don't have to take just those pairs. I can take any x and any y. If I take 2 plus 17, that's 19. Subtract 1, that's 18. That's also divisible by 3. So no matter what combination you take, and that's pretty good confirmation to me. In other words, I've got all these numbers, and no matter what combination I use, I get something that's divisible by 3. Okay, how about number 4?
four knots, A, B, C, and D, appear in that other along a straight length of rope? Is the distance between B and D the same as the distance between A and B?
Now, obviously, that's not to scale, but they're in order like that.
Mm. The distance between A and C is less than the distance between B and D.
Okay, let's change my picture around a little bit to reflect that. The distance between A and C, so I'll make C right there, and I'll make B over here. So now AC is less than BD. And what we're trying to figure out is the distance between B and D the same as the distance between A and B.
Well, right now the answer would be no, it's not. But can you draw it so that it is?
Yeah, good question. Let's see if I can. So for that to be true, B would have to bisect, right?
Mm-hmm.
So here the distance between B and D is the same as A and B. Now the question is, can we put a C in there?
No.
That's right, because even if I put C right there, that makes the distance from A to C greater than B to D.
So one works.
One works, and we can answer it in the negative. In other words, we don't have to answer that with a yes to be able to answer it. We just have to be able to answer it. And that's a key thing with data sufficiencies that it takes a while to get used to. Because it's real easy to make the mistake of, well, no, AB is not the same, therefore we can't answer it, but we can. So one is a yes. Okay. 2, half the distance between A and D is the same as the distance between C and D. So what that tells me
that C must be right in between.
right, which means I'd have to move B out of the way. B can't be there. So C has to be there. Is that what that's? Half the distance between A and D is the same as C to D. Yeah. I mean, C bisects A and D, and it forces B to be over there.
So the answer is again no to the question, which means...
Right. In other words, B would have to be on top of C for it to be yes.
So both 1 and 2 works.
Yes. So D again would be our answer on this. Oh, I don't have the test. I don't have the answers. Sorry. I never thought I'd ever say this, but we're almost getting good enough that we don't need the answers. And I tell you what, I worked in GMAT for 2.5 years, and I never would have stated that. And I still won't, because I know they got lots of tough ones in them that are tough and tricky and real easy to get it wrong.
I'm just saying that I don't need a 800, so it's okay.
Yes. Yes. Okay, is X greater than Y? X is the arithmetic mean of all 2-digit prime numbers less than 23.
Okay, so that is 11.
For one thing, it's a no instantly, because it doesn't address Y.
Why? Y is the sum of all factors of 60 that are greater than -1 but less than 6. Well, no.
For the same reason. I think it has to be that. In other words, if it says nothing about, the other variable, it can't possibly say whether x is greater than y, right?
Mm-hmm.
All right. So we knew all along that it was going to come down. I mean, the moment we see that, we know it's just a question of whether both of them together or not. So if the test was about to run out, we'd have a 50-50 chance of guessing right,
Mm-hmm.
which is good. Okay. So now let's figure out what these numbers are. X is the arithmetic mean of all two-digit primes.
17, 13, and 11.
Oops, two-digit primes only. Huh. So the average of that, since those two are separated by 2 and those two are separated by 2, I know that 15 is the average without having to do the math.
Mm-hmm.
So x is 15. Y is the sum of all factors of 60 that are greater than -1 but less than 6. Do I
Okay,
need
then
to go?
zero is that number.
Well, do I need to go through that math?
No, because they would all be less than x.
Ooh, there's only one reason I might need to go through that math. And that's if y came out to be 15.
But how can y be 15?
Well, I don't know. I haven't even bothered to look at the math that I'm going to have to go through.
Mm-hmm.
My first instinct was to say, well, this is going to come out to some number. As long as we know what x is and we know what this number is, then sure, we can answer the question, is x greater than y? But then it occurred to me that if y happens to come out to exactly 15, we cannot answer this.
Mm-hmm.
Yes, we can.
Then
Yes,
the answer would be no.
the answer would be no. So it doesn't matter what number this comes out to be.
Mm-mm.
Whatever number it comes out to be, I'm going to be able to answer is x greater than y. If this comes out to be 15, the answer is no, but I can answer it. If it comes out to be any other number, I'll be able to answer it also with a yes or a no. So I'm inclined to think that they put all this gobbledygook in here on number 2 in order to weed out the people that are going to go through all of that. You don't
Yeah.
need to work out that number. And
Okay.
okay,
Well, the answer is D.
yeah, let's
Or
do
C, I mean, C.
yes, C.
In a boat race between David and Jeff, when Jeff had covered half the 30-mile race distance, David was 2 miles ahead of Jeff. How long did it take David to travel the entire 30-mile distance? Okay, so when Jeff covered half the 30-mile race distance, David was at 32.
And half of 30 is 15. So
17.
this is Jeff, and this is David.
And how long did it take David to travel the entire 30-mile distance? David traveled the last 15 miles of the race distance in 40 minutes. I would say 1 is no.
How long did it take David to travel the entire 30 miles? Well, we don't know how long it took him to cover this first 15 miles.
No,
So
that's why I
telling
was
us,
saying 1 is no.
yeah, so 1 has to be no, I think. I agree.
And then I would say that 2 is no for the same reason, because Jeff traveled the first 15 miles of the race distance in 45 minutes. Well, you don't know how fast, if he was sailing faster on the last 15. I mean, you can figure out how you know, in both of them you can figure out how fast he sailed in 1 minute, you know?
Well, the other assumption we can't make is that they're going to go the same speed the whole race. I don't think we
That's what
can.
I mean. Like, that's
Yeah.
why I want to say that you can't solve it with one
Right.
or two.
Right. Okay. So we don't know. The question is both combined. So it took Jeff 45 minutes to do that first 15 miles.
Which
And it
means it
took
took
David
David 45 minutes
45 minutes
to
to do
do.
17 miles.
Mhm.
David traveled the last 15 miles of the race in 40 minutes.
But 2 of those miles are in the 17.
Right, so from there to there is 40 minutes.
So you would have to take
We
2
don't know
miles.
how long it took him to do this 2 miles right there.
No, because they say it's 15 over there. I mean, you could say 17 into 70 into 45 and then minus that, but I mean, I don't know if that's right.
Well, we know it's something less than 85 minutes, right?
Mhm.
But could it be 85 minutes? In other words, if I can come up with two answers, we can't answer it. Well, let's
No,
assume,
I'm gonna say E.
yeah, that's what I would say also,
Mhm.
because David can do these first 15 miles in 44 minutes and this 2 miles in 1 minute.
Mhm. Or he can do the 15 and 44 minutes and the 2 miles in
Right.
2 minutes.
And then the final answer would be 85 or 84 or 83. It could be a number of different things.
Mhm.
So I wish I had the answers because I remember this problem and I remember it being tricky. I remember it
Yeah.
being not the answer that I thought it was. I think you can figure it out, and yet I can't see how. Jeff traveled the first 15 miles of the race in 45 minutes, which means David went the first 17 miles in 45 minutes. Now, I don't know. I'll think about this. If I come up with any new thoughts, I'll let you know. But at the moment, I got to say E, but I have my doubts.
Mhm.
I don't know
I
how we're.
mean, if I was on the test, I would have said E because
I
you
would
know.
too. I would too. This logic seems
I mean,
sound.
it's either E or C.
Right.
You
Right.
know, it's either or. It's not like one of them can. So it's 50-50%.
Right. And it
Of,
certainly seems like E uh, is correct based on this logic. Unless there's something we're not seeing,
mhm.
based on we don't know how long it took him to go that last 2 miles. That's the key,
Mhm.
which is part of the 40 minutes that it took him to go the last 15 miles.
Mhm.
And we don't know how long it took him to go the first 15 miles either. So, okay.
Well,
Well,
I
we're getting our practice with data sufficiencies. This is
yeah
kind of good. I like doing it this way.
yeah it works really well.
Well, every other time I've ever done GMAT tutoring, when you do nothing but data sufficiencies right off the get-go, it's really demoralizing. They're so hard. And
Yeah, it
so
really is
doing it the way
confident.
we did it, where we just did a few a day, and then we gradually worked up to more and more, and then today we did 30 minutes of data sufficiencies, and it didn't seem overwhelming.
Mhm.
So,
Yep.
okay.
Okay.
I will talk to you the next time, Cecilia.
Yep. Have a good
You
rest
too.
of
Have a
your
good
day.
weekend. Okay, bye-bye.